So, a little bit of vocab, and this could quite possibly be some easy review for you depending on what curriculum you've done in the past. Usually this is like an Algebra 2, Algebra 1.
I don't remember.
Well, hopefully it comes back to you. So, a relation is just relating, not a great definition. We use the word in the definition. Two quantities together. It should be TWO. Yeah. So here we're just doing like X and Y, but like when you're teaching this to freshmen, you're like, when a guy's dating a girl, that's a relation. You're comparing these two people together, and they're like, oh, that's so weird. But basically,
I've never heard it explained like that.
I know. It's also probably because you haven't been in public school, high school class room, and you do anything you can to get kids' attentions.
Mm-hmm. So these, when every I like it when they only have one corresponding y value.
So a function is a specific type of relation. You for sure have, I'm guessing. This is pretty late in the curriculum to be teaching it. And then domain and range are just the possible x values and the possible y values. For most of the equations people work with, domain is all real numbers. You can always plug an x in, but then there are a lot, especially like when you get to algebra 2, there's going to be a lot where you have to be a little bit more careful, but we'll talk about both of those. So the easiest way to determine whether it's a function or not is called the vertical line test. So if you graph the equation and then draw a vertical line anywhere on that graph, you're trying to make it where it hits the graph at more than 1 point.
Oh, I remember doing that.
On that graph, is it possible to hit more than 1 point?
No.
So it's a function. If we had a circle-ish, I could draw a vertical line there and it hit 2 points, so that's not a function. Okay, all you gotta do is show one spot where it hits more than 1 point, and now it's not a function. Okay. And that's what it means to have more than one y. So this x value here, let's say it's -2. Well, -2 could go to +4, or it could go to -4. So for functions, I will explain like a keyboard. When you press the letter G on a keyboard, what happens? A G. It would kind of suck if a keyboard was made in a way where if you press a G, it could either be an I or a G. Right?
Yeah, that would suck.
So a keyboard is a function. When you press something, something happens, and it's the same thing every time. It's like driving a car. If the gas pedal could be both gas or brake and you don't know which one, that wouldn't work very well. So that would be a function. The other one, have you guys ever like gone to, and I think they're all over the place now. It was special when I was a kid. Those like penny machines where you put a penny in and then spend $4 and then crank it for like an hour.
I like those.
Yeah, and then it spits out. So when I was a kid, those were only at national parks. And then people are like, oh, this is cool. Let's put it in our Roaring Rapids pizza place, and it's not cool anymore. I mean, it's super cool. So that's a
But
function.
no one wants one for Roy Rabbit.
I get them at like the zoo and Enchanted Forest.
Well, sorry.
Sorry.
Set notation. The only thing you really need here are these three parts. And then I'll show you some examples here in a minute.
Union U.
Yeah, use the symbol.
Never seen that.
This is probably specific to pre-calc. So brackets, think of less than or equal to or greater than or equal to.
Ew.
Parentheses are less than or greater than. Union means and.
Set that is not included in what, a function?
No, like the x values or y values.
Wait, so it's just a U?
Mm-hmm.
Okay.
So a union's about what you think it is. If you have a number line that goes 3, 4, 5, 6, 7, and this set makes the relation true, and this set makes the relation true, but notice how they don't connect. A union is just adding those two sets together. So you can skip over that part in your notation. A U just skips that part, basically cuts it out. Cut it
So
out.
needs that lame part.
So example 1, f of x equals 2x.
Oh, now I remember. I remember doing this now.
So f of x is just the same as y. It represents our domain values, what gets spit out by the equation. Y is our range values. X is our domain values, that's what we're plugging into the equation. Okay, so is this a function? Yes, because it's just the line, right? So the domain here is going to be parenthesis. Is there any x value that you can't plug into that?
No.
So it'd be negative infinity, comma, infinity.
Oh, dang.
Oh, I don't know how to do it. Putting symbols.
It's like
It's a sideways 8.
Sideways 8. I know, but how do you get it right?
like
Oh, there we
this.
go.
That's why I just do 2 circles.
I did it.
Two
That's
circles.
bad drawing 8 as 2 circles.
Range, is there any y values that a line wouldn't hit?
No.
So that would also be negative infinity to infinity. Notice how I use parentheses there?
Why did you make them first?
Because that's the left side of the graph.
Oh, okay.
You go left to right when you are looking at this stuff. I think on Desmos, or not Desmos, formative, if you just type in INF, it'll change it to an infinity symbol. You might need to spell the whole thing out, but either one. Okay, questions on that?
No.
This week should be a nice breather compared to the last couple of weeks.
Good. I'm tired of not breathing.
Absolute value of x. What does that graph look like?
Isn't absolute value the opposite? Or
He
like
said it's
from
just positive, isn't it?
You make everything positive, yep. So what would the graph look like?
only on this side?
No, because you can plug -3 into that, right?
Yeah, but then wouldn't it be
But it would be 3.
3?
So you get +3. You can plug -2 into that. You can plug -10 into that.
But there's no limit to what you can plug in. It's just all
Right.
It would just
positive.
be all real numbers. Or, wait, no. Real numbers are negative numbers.
It's a V. So picturing these graphs, and or even graphing these graphs like on Desmos or something is going to be helpful, because we know for all of these it's just going to be equal to itself, right? Like we plug in 1 in, we get 1. If we plug 5 in, we get 5. So you get a line with slope 1. We're tracking that. That makes sense.
Wait, what? Yeah, I understand why we get a line.
So this would be like 2, 2. This would be 5, 5. Because whatever you plug in for x, you're going to get out for y.
Yeah.
And then it's going to be the same thing the other direction. Because when you plug -1 in, you get out +1. When you plug -6 in, you get +6. So it's that same line, just on the opposite side. So absolute value is always a v.
Is it a function?
Not a function.
It is a function.
No.
Because if you draw a line through it, it's only gonna hit one.
It's basically
point.
2 lines combined
that's-
together, right?
Oh yeah, cause if it's a relation, if it's a relation, then there's 2 points?
So a function is a relation.
Oh,
So that, it's kind of, people explain it like this. Like you've got a big umbrella, that's relation. But then you've got a smaller umbrella under it, that's function. So a function is a relation.
But there's only 1 point when you draw a line?
Yes.
that's how you know it's a function. If it hits more than 1 point, then it's not a function.
So the domain here, is there anything we can plug in or anything that we can't plug in for x?
No.
So it's again -infinity to infinity.
And beyond.
The range, are we going to get every possible y value?
No, it's only gonna be positive y values.
Okay, so what's the smallest number we can get?
0.
And will 0 be on the graph or not on the graph?
Yeah, it'd be on the graph.
So if we plug 0 in for x, what do we get?
0.
So our range would be a bracket, 0, comma, infinity.
Oops.
My bracket looks like a bed staple.
That would be the same as saying x is
Wait.
greater than or equal to 0.
You put a bracket on one side and a parenthesis on the other?
Uh-huh.
Oh, why?
Can you ever reach infinity?
No.
So there's no ending there.
But it ends at, but it's equal, it's 0, it ends at 0, but it also includes 0. So that's why it's a bracket. I think.
Okay. Because
So a parenthesis is sort of kind of a limit, which we haven't done. I think we might do it towards the end of this year. But a limit is just like you can approach a number, but you never touch it. Physically, this doesn't quite make sense, but like if I walked half the distance to the door, I'd be like right there, right?
Then you do another half.
Another half,
You'll
another
never
half,
get there.
another half. Technically, I would never touch that door. Real world, I would touch that door.
Just
right.
In a very long time.
Right. So a limit's that same idea. So a parenthesis is kind of like a limit, because if you, let's say 0 wasn't included on this, and we'll have an example later where it's like a number isn't included, you can get as close as possible to that number, but you can't touch it. You could be like 0.000000000000001, and you still haven't touched it, right? So a parenthesis is like you can get close to it, but you can never touch it. Infinity, you can like, it's like a rainbow. You can get close to it, but you're never gonna touch it. It's always gone.
you can include 0 if you bracket on the 0.
Mhm.
So the bracket is you can touch the door, but you can't go past it. Yeah. Is that a function? That's a lot of numbers and squiggly lines.
Mm-hmm.
Oh,
So this is called a piecewise graph,
piece.
or piecewise relation.
You never understood how to draw those line things?
Yeah, I haven't either.
Squiggly brackets.
It's just kind of like,
Like the top half of a pumpkin.
so this, take a minute to try and graph what that's saying.
Ew. Ew. So is the top saying negative one,
It's
that y
saying-
is -1 if x is less than or equal to 0?
Yes.
Y is -1. If -1. Wait.
that'll sound nice on the recording.
Wait, you audio record it too?
Yeah. You're just gonna post a video with no sound? That's not gonna be any helpful.
-1. So y is -1 is x.
It's less than or equal to 0.
Less than or equal to 0. So it's -1. Less than.
So x is 0, then y would be -1.
But if x is greater than 0, but not equal to 0, which means you have to put a parenthesis.
If it's greater than
You're not gonna put a parenthesis on the graph though.
Oh, right.
So how do you show that on a number line?
So wouldn't it just be
An open circle.
Yeah.
but there's only gonna be 2 points for y, right?
Nope.
Why would it be 2 points for y?
But it was -1.
I did it right, I just forgot to put the circles.
Because if x is 4, what does y equal?
2.
If x is 15, what does y equal?
2.
If x is 1,000,000, what does y equal?
Oh, I get it now. One of those things.
One of
like a
those.
number graph.
Yeah, weird. Maybe a number line.
Yeah, those things.
So, is this a function?
Yeah, no, yeah.
Because it can go, no, it's not,
No,
because it
then
doesn't
they-
actually go to 0. You're stomach.
Okay, I think it is not. Oh, no, it is not. Okay, come on.
Yeah, it's a function.
Because the only...
The open circle isn't actually 0.
Right.
I know.
If you drew a line there, you hit it here, you don't hit it here.
I said no as my brain was like, no, but yes.
And you check to see how they like to write This is lesson 19.
Yes.
So domain is -infinity to infinity. The range is -1 or 2.
So that's when you use the u.
No.
That's when you have 2 sets of something.
It looks like you can just say -1 or 2.
Oh, okay.
Oh, because that's the y. Wait. No. That's it. Wait. The range is y, yeah.
Okay, we good on that?
Yep.
All right. So 1 over x, I'm pretty sure we talked about this. We did. A week or two ago. First off, before you graph it, is there anything x cannot be?
0.
X. What?
0, because you
Zero.
can't divide by 0, right?
0 divided, yeah. No.
So your graph is going to look like this.
Hyperbola.
It's not a hyperbola.
Parabola.
It's not a parabola.
Oh.
It's like
It's a rational function.
okay.
Hyperbola looks like that.
Oh, yeah.
No, right.
And a parabola is the other
Wait.
way.
But why?
A parabola is like that.
There's only one.
Wait, but why?
Because it never touches 0, because it can't be 0.
So should it technically be almost 2, 0?
Yeah, but it goes on forever. It's got a downward angle.
Yeah.
It'll get
But
there.
why is it on both sides?
Why is it over here and over here?
Mm-hmm.
Because if you plug -4 in, what do you get?
Oh. -4.
-1/4.
Or -1/4, I mean, yeah.
So that's why it's on both sides.
Okay.
So is this a function?
Yes.
Mm-hmm.
Yes. Now for the domain, what do we not include? But it's on both sides, right? Yes, it's on both sides. Great. So we'll do -infinity to 0. Do we include 0 or not include 0?
No, it's a bracket.
Parenthesis.
Oh.
Because we don't include it.
It's not included. All right.
Huh, even then,
union,
mess me up.
and then 0, infinity.
You should go to. Okay, I get it. The range is any number except 0.
And why is the range not 0?
Because it doesn't touch 0. Oh, the
Why not?
range?
Yeah, why don't we touch 0 with our range?
Because it'd be undefined. Because you can't.
X is undefined, but why won't we ever get a 0 when we-
Oh, in the range.
in the range?
Because
Because it doesn't touch 0, that's fine.
So the only thing you can plug in here is X's, right?
Mm-hmm.
If you plug in 1,000, 1 over 1,000 is not equal to 1, or equal to 0. It's close, but not equal to 0. If you did 1 over 1,000,000,000, is that equal to 0? But it's close. If you did 1 over 1,000,000,000,000,
Googleplex.
you're awfully close, but still not quite there. Okay, so it's one of those limits we were talking about where you get close to 0, but you're never going to cross it because there's nothing to plug in that will actually equal 0. You get smaller and smaller and smaller and smaller and smaller, but you'll never quite hit it. So this would also be negative infinity, 0, parenthesis, union, 0, infinity. Okay? The last thing is evaluating functions by substitution. All this means if you have a function of fx equals x squared plus 2x minus 4, and we want to plug numbers into that, how it's going to look, you'll have f of 4 equals, and then wherever you see an x, you plug in that 4. The left side is just telling you what did you plug in. It's not actually part of solving the equation.
Shouldn't be a space part, not a part.
I don't know. So when you plug 4 in, you get 20 out.
Okay.
What are you saying I did wrong?
And fx is not a part of solving. Should be a space part.
No.
it's not included in solving.
She's saying like the spelling of apart.
I don't know how to spell. So.
Oh. Why would it be that?
No, because a part would be like, I need a part for my car.
Yeah.
A part
Part is a
is
verb.
like
Isn't it?
two things. You're getting way too
Part-
technical
part
there.
Is a noun.
Well, yeah.
Or you could like part
This
something
is why
like,
we're not English
part with
teachers.
C.
man.
but like
I tried to type in apart and it went straight to apartments, and now it's trying to find me apartments for it.
cheap apartments near you.
For only
as in
$600 a month.
It's an adverb.
Adverb, that's what I meant.
No, you didn't.
I'm sure it is.
I should try though. 2x minus 4.
So you can plug anything in and get something out. So that you could plug in f of sine of theta, and you would get sine squared theta plus 2 sine theta minus 4. Right? So just knowing that function, this is called function notation. It's once I understood function notation, how simple it was, because it was, again, one of these things where when I was in high school learning this, it didn't make sense, because I was like, this is so easy, there has to be something hard about it. It's really not. It's like, just, it is what it is. So, don't make it hard, it needs to be.